Okay, hello again. 18. So we have this formula. A perimeter is twice the length plus twice the width, and which formula shows how the length of a triangle can be determined from the perimeter and the width. So we want to solve for length. Okay, so we're going to take this perimeter and we want to get L by himself. So the first thing here to do is take 2W away from both sides. And so then that gives us P minus 2W equals 2 times the length. I'm just going to do that for an L because that looks like a 1. And so now I'm going to divide both sides by 2. And basically L is equal to P. Let's see how they do it. Yep, they let you keep it, thankfully. And that's it. So that would be B. All right, moving on to 19. So this would be a good candidate for completing the square. And I know you all like to avoid that like the plague. But the thing is that you have this lovely little even number here. So if I do that, I'm going to take this part. I'm going to add 27 to both sides. I'm going to zero it out on the left and add 27 on the right. And now I can create that perfect square. So I'm going to do that by cutting this in half, which gives me 3, and I'm going to double it, or sorry, square it, times 9. And so now this is my new function, but remember what I do on the left, I have to do on the right. So now I have x squared minus 6x plus 9 equals 36. This can be x plus 3 squared equals 36. And so should be x minus 3 because negative times negative is a positive. Sorry about that, guys. All right, and that makes it C. Moving on, here we're going to get into box plots and histograms and all kinds of statistic stuff we haven't taught yet. I'm sure you're just thrilled about that. So you're going to look at these histograms. This all refers to team R. So how many 4-minute times do we have here? We have 1, 2, 3. Looks like there's only 3 4-minute times. These are all 3. Oh, this one says 4 4-minute times, so that one's not going to work. All right, how many 5-minute times do we have? We have 1. Oh my goodness, I erased over there. I wrote over this one. Sorry, guys. Back to red. So 5-minute times, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 5-minute times. Looks like that one's good. That one says 7. That's not good. So that one's not going to work. So now how many 6-minute times do we have? We have 1, 2, 3, 4, 5, 6. 6-minute times. So let's see, that looks like D. Nope, because we also have A is still in the running. All right, let's just keep going. So now we have 7-minute times. We have 1, 2 7-minute times. It looks like 1 8-minute time. So who's got 2 7-minute times and an 8-minute time? That would be D. Okay, so that's how you're reading your bar graphs here, is you're just looking at the data and how it's put out on the frequency table. All right, next. This is where it's going to get a little interesting because you have to understand box plots, and I just don't have time right now to teach it to you. So the median is going to be this line in the middle of the box plot, okay? The interquartile range is everything in here. This is the middle 50%. So this is the first 25. This is the last, this is at 75. So this is the middle 50%, from 25% of the data to 75% of the data. And that's why the green line here is the median, or 50%. Okay, so now, knowing that, the data for team S is an outlier. outlier, oh, includes an outlier. An outlier is something so incredibly out far away. So we would be talking, an outlier would be something like maybe 25. I see no outliers for Team S, or yes. The data for Team R is skewed to the left. Okay, so skewed means shifted, well, shift is not a good word. Basically, you have to think about skewed like you do when you do transformations left and right. It's opposite of what you think. If it's skewed left, then the data is hugging the right wall. So this data here would be skewed left. This data here is skewed right. I don't know why that works. It has something to do with averages. But you know what? As long as you remember skewed left goes right and skewed right goes left, just like transformations, you'll be okay. So here, the data, I'd say it's skewed to the right. So this would not be correct either. No outliers, no skewed left. Interquartile range, again, is inside that middle box. It's that middle 50%. So this is the interquartile range, and here I just highlighted it green. And so let's see, the interquartile range of Team R is equal to the interquartile range of Team S.